Hey guys, so just like I said, I am going to go over some other study material that I didn't go over in the earlier videos. So this is part 5 of all the videos that I've put up so far. So in this video, it should be short. I'm just going to go over Pulley Systems. Um, well, essentially what mechanical advantage is and what ideal mechanical advantage is, as well as a little bit of review on Matlab. And then I noticed there was a lot of errors in multiplying units together, so multiplying and dividing units together, I guess I should say. So um, it's both of those, I guess. There's just like easy points that some of you um, missed out on, but we'll, I guess, touch on it in this video. That way you guys don't make that mistake again. So um, first of all, so Pulley Systems, there is a system, there's a problem in the review that I handed out to you guys on, well, to my class, my workshop specifically on Thursday. And then there's, if you're in the other section, or if you're in Queenie's section, I don't know if she handed you guys out, or if she handed out some final review problems with the solutions on them. So, like I said in another video, if you don't have them and you want them, just ask me and I can provide those for you as well. Or maybe I'll just like attach them to an email that I send out when I tell you guys about all these videos or something. But um, yeah, so there's a solution uh, in that um, in that paper for that problem, that specific problem. But some of the ideas might be a little bit obscure, so mechanical advantage, for example, is simply the load force divided by the effort force. So you're in a pulley system, for example, your effort, if you have like the ideal pulley system to where uh, just like that ideal pulley system where you are only pulling 1/8 of the weight, um, that 1/8 is considered your effort force, 1/8 W, and your load force is considered just W. So your mechanical advantage is W divided by 1/8 times W, which is simply 8. So like in the problem that I went over, or in the problem that's in the review, their pulley system divides the load into, it divides the load to where you're only pulling 32, um, like 1/32 of it. So pulling 1/32 of that load is almost nothing. So it's great. It has a great mechanical advantage, but the distance that you would need to pull down on that thing in order to bring the system up would be uh, you'd have to pull down on the rope that you're pulling down on in order to even get the load, whatever load it is, to barely move at that point in the system. So that's where it compensates. So if you're if you really need to move like a huge like big block or something, um, just a little bit of distance, then maybe a pulley system is something that you should consider implementing in whatever you're doing. Okay, so mechanical advantage is just load force divided by effort force. Ideal mechanical advantage is force output divided by force input. So in this case, force input would be um, like we have this fulcrum here, like a seesaw kind of thing, um, and your effort force or your input force is, I should have labeled it, but it's here, this arrow here, and your output force would be essentially the weight here. So I know that's like, it's like, wait, what are you talking about, Charles? Um, so because like, just like we spoke earlier, or how we talked about earlier in class, the distance here is obviously a little bit shorter than this distance here, and for that reason, we may put a little bit of effort, a little bit of force input here in order to um, balance out this force here. So in terms of ideal mechanical advantage, force input is obviously what you put into the system. Force output is what you're obviously getting out of the system. So that is calculated as ideal mechanical advantage. Let's see. I might go back to this depending on the little research I do here in a bit, because I think I might have explained this a little odd, like. But anyway, I'm just going to move on to the Matlab review. So as far as Matlab goes, what I would remember if I were taking, or if I were about to take this exam, or well, essentially what I would recommend you remember is a few things. So remember that one, this percent sign, a percent sign is used to make comments in your code. So when you're writing code, you'll have a bunch of stuff like x is equal to this, y is equal to this, and you'll have if statements, you'll have while while loops, you'll have for loops, you'll have a bunch of stuff in the code that is specifically meant to be put there. That way your code works properly. But sometimes you want to know where, like what this particular part of the code is doing. So in the code, you may write, Matlab has set this to where if you put a percent sign down and anything you write after that percent sign means nothing to Matlab, and it's just going to leave it alone. So I think this like kind of replicates Matlab. Yeah, so it turns green. In Matlab it turns green, so you can comment something like this, and it will come out. Matlab will ignore this entire line, so like this entire line 3. And then later on you can have like your code, like your for loop or your while loop or your if statement, if x or if I equal to some number, I don't know, and so forth. So the next thing that you might want to remember is that fprintf. I don't know if you guys use this specifically, but fprintf is usually used to display text in the command window when you're running a code. So when you write your code, when you finish it, the majority of times the result will be displayed in the command window versus in the script window, which is the window that contains all your code. So fprintf, you'll have some stuff here in the middle of these parentheses of fprintf, and it's almost to where like whatever you write here will come out as whatever you write there without fprintf in the command window. So I don't think you'll be like tested on this particularly, but it might be there. So I'm just going over it. I'm going over it anyway. So I think that's all I'll say about that. But I think these two are probably the most important. The most important things from Matlab that you guys should know. So when I say that x, when I define x as being equal to linspace, I'm saying that I'm essentially saying that x is equal to a matrix of one row and multiple columns. So this 0 here represents the beginning value. This 1 here represents the final value of the matrix, and the 5 represents the number of Oh my god, I lost this word again. Um, the number of numbers within this matrix. So if you type this into Matlab, what you would get is something that looks like this. You'd get 0, the starting value, and then you'd get and you would get this because so like I said, this is the number of numbers in the matrix. So right here we have 1, 2, 3, 4, and 5 numbers in this matrix. The ending value is 1, which is what I have here, and the beginning value is 0, which is what I have here. So that's what lint space does. So the important thing to get out of this is what these numbers represent. The beginning value, the end value, and the number of I have to find a better word than numbers for this. I think you know what I mean, but I'm just gonna leave it at that. Okay, so now as far as this goes, this operator here, the column operator, the colon operator, what it does is it'll take, when you write this out in Matlab, Matlab will read this as a beginning number and this as an ending number. So what you'll have is something like 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So what this colon operator does is it gives you integers between 0 and 10, and it puts them in a matrix. So you end up with all these terms in this matrix, and that's essentially all the colon operator does. So out of all these things, I want to say these two are probably the most important for the exam. But you didn't get any review problems on Matlab in the handout that I handed you guys. So there's a good chance that it won't be on there, but just in case, I just thought I'd go over it. So okay, so finally to multiplying and dividing units. So in, I think it was like the second exam, I think. I saw some, you had a number like 5 feet. I'll use the equation thing, the equation tool here. So you had like 12 feet, for example, times let's say 2 feet. And you're supposed to give the answer here. But obviously you guys I think everyone got it right, the number anyway. So the number is obviously 24. But what some of you guys put was 24 feet. But that's wrong because you're not only multiplying the values here, you're also multiplying the units. So you get 24 feet squared. So make sure to take note of this. That way you don't make any mistakes like that, if there are any smaller questions like that in the exam. Okay, so I think that's pretty much it, and and words not responding, whatever. Oh my god. Okay, so I think that's pretty much it. If you have any other questions, of course, please email me. I'll be free tomorrow after maybe about 6 o'clock or so, and I'll be done with pretty much everything. The only thing that I have to do on Thursday is go and attend your final exam, and then some other like stuff on Friday, but that can be done at another time. So if you do have any questions, please email me or text me. I've been like providing my phone number in like the emails and stuff, so you can get it there. Um, Either way, just let me know. And I just want to thank you guys for being a great class, and it was fun. I hope you had a fun first semester for many of you, I know. And I shall either talk to you soon or see you on Thursday. So good luck, and I'll see you then.